Welcome to qnawire.
With some row reductions, we can take the second row and we can get a 0 by taking the second row and subtracting 2 times the first row. So row 1 and 3 will remain the same, and row 2 would be 2 minus 2, which is 0, negative 2 minus 4, which is negative 6, and then 4 minus 10, which is also negative 6, and negative 12 plus 24, which is positive 12. From here, we can get a 1 in row 2 by scaling it, by multiplying it by negative 1, 6, or dividing by negative 6. So again, rows 1 and 3 remain unchanged. We'll have a new row 2 of 0, 1, 1, negative 2. Now we can get a 0 in row 1, column 2 if we take row 1 and subtract 2 times row 2. So this will be a new row 1. So that would be 1 minus 0, 2 minus 2, 5 minus 2, and negative 12 plus 4. Rows 2 and 3 remain unchanged. And then we can get a 0 in row 3 by taking row 3 and subtracting row 2. Rows 1 and 2 will remain unchanged. And so we get 0 minus 0, 1 minus 1, negative 3 minus 1, and 14 minus negative 2. 14 minus negative 2 would be 14 plus 2, or 16. Then we can scale this by, and I'm going to erase, by divide by negative 4, or multiply by negative 1/4, so we get 1 and negative 4. Okay, now we just need zeros above and below. We need zeros above the 1 in row 3. Let's start with row 1. We can get a new row 1 by taking row 1 and subtracting 3 times row 3. That'll give us a new row 1 of 1 minus 0, 0 minus 0, 3 minus 3, and negative 8 plus 12, which is 4. Because that'd be negative 3 times negative 4. And so we have negative 8 plus 12, which is positive 4. There we go. And then we have one more operation to do. That would be to get rid of the 1 in row 2, column 3. We can do that by taking row 2 and subtracting row 3 from it. And we'll get a new row 2 of 0, 1, 0. That's 1 minus 1. And negative 2 minus negative 4 would be negative 2 plus 4, which is positive 2. Rows 1 and 3 remain unchanged, and now we're solved. X, Y, Z, now that we have the 3 by 3 identity matrix on the left, the solution is 4, 2, negative 4. X is 4, Y is 2, Z is negative 4. To find the inverse of a matrix, augment the matrix with the 3 by 3 identity, and we're going to row reduce until we get the 3 by 3 identity on the left. Then the result will be the inverse on the right. So let's begin by getting a 0 in row 2 by just adding rows 1 and 2 together for a new row 2. So that would be 0, 3, 5, 1, 1, 0. Let's get a 0 in row 3 by just taking row 3 and subtracting row 1 from it. So 1 minus 1, 7 minus 4, 8 minus 3, 0 minus 1, 0 minus 0, and 1 minus 0. Now we can actually see already that this isn't going to work because of these two rows right here. We have 0, 3, 5, so they are the same thing. This isn't going to be able to work. We're going to end up not being able to get the 3 by 3 identity. I can continue this process if you'd like, because we would just divide this by 3 to get a 1 in row 2. And then to get a 0 in, actually I don't even need to do that. I'll tell you why, because we could just say let's get a 0 in row 3, and you'll see very quickly okay. I suppose I could just erase that. If we just subtract, we'll get 0, 0, 0, negative 2, negative 1, 1, but that's going to create a real problem right here. So again, this just tells us that the inverse does not exist, and so we can write DNE for does not exist in any cell. Hope that helps.